of everything. What we can do is we can continue along here. So in this particular case, we're going to start from this location down in here. Let's view it 1-to-1 so we can see this in its entirety. So we're going to start from this point 19. So all we have to do is go to the last row, and we can right click on this point, or we can just enter this explicitly as 19. We're going to set this to road because this is also road. And what we're going to do is we're going to specify, now curves can be entered if they're tangential. They can be entered directly just with the radius and curve. If they're not tangential, then there's a convention that's used in this program. Now, in this particular case, this curve is tangential to this direction, but it's not tangential to the way that the entire traverse was entered. So what I need to do is I can either specify the radial bearing, which would be 90 degrees off of this line, or I can specify the chord bearing. So if I don't specify a chord distance, it will assume that it's a radial bearing. If I specify a chord distance, it will assume that the bearing is a chord distance. So in this particular case, I'm going to use the radial bearing. Now I can either enter the radial bearing as 90 degrees off this line. I can actually enter angles on these lines just by entering a plus sign and 90 degrees, which will be clockwise angle, and minus 90 is a counterclockwise angle. So this is measured off of the last course. So this would be here, this would be counterclockwise, this would be clockwise. So you can see that it's really the minus 90 will give me the proper direction. If I enter a space or a dot in the distance, then I can enter the radius, which in this case is going counterclockwise, which is minus 5, and the arc distance, which is 7.85. And then I've got my point 20. Now again, I can continue entering this. This is also the forward tangent coming off of this curve. Now it's quite a bit off. It's like 3 minutes off, but it's also a very short curve, so it's likely very close to the location. So we're going to come off of this this curve, north 72, 44, 40, go 16, 4.05. Now hit the dot in the bearing, we'll clear the bearing and distance. We go to radius. Now this is counterclockwise curve, 30 meters radius, 12.29 and 5.74. So since this is all a tangential curve that comes around this chord, I can just specify the new radius, which at this point is 18.5. Now this is going clockwise, so 18.5, 11.81. And my next course is 11.35. As you can see, it always copies the radius and the arc length, or the bearing, the distance, down to the next course. So in this case, because all of these curves are 11.35 around this this cul de sac, I can just hit return in order to locate all of those curves. This can also happen in straight lines, but there's just not that many straight line duplicate locations on this subdivision. And then we can go 11.81 to end the curve. We change it back to negative 30 is my radius, 5.74, 12.29, and then we're coming off of the curve. Again, because we have a number of curves in here, we've got a little bit off in the forward tangency, but we're going to just accept that. So we're going south 72, 44, 40 west, 20.4. And then to close out, we're going to have, in this case, again, it's kind of difficult to read, but we can always turn this off temporarily just so we can see what's going on. So this is going to be radius is minus 5 and the arc length 7.36. And it's automatically detected my closure again within a tolerance. In this case, we've set our tolerance to 0.1 for finding an automatic match. And we've got 0.03 as that closure. which is still within our tolerances. So what I'm going to do is turn the lines back on again, and then we can save this again. So we'll save this. I'll just call this PV2.